So we can now discuss generalized current these functions, and like conduction current G on a metal strip may be decomposed into a longitudinal part JZ and a transfer part JX. And so the current components may be described by these expressions. Correspondingly, the basis functions are Jxm defined by again by these expressions. And what we can do is that for better numerical efficiency of the solution, the current basis functions with H similarity employ to model a longitudinal current distribution on metal wires, and it can be given by this expression. But the transverse current is not singular. So the basis functions described by this expression are orthogonal in nature, and this Jzn has this function values. So we also know that the current basis function can be Fourier transformed, so we can use them in the analysis when we do spectral domain study. So the Fourier transform is defined by this for the case of JZN. And then, so this expression involves the Bessel functions of the order 0, and the later current basis functions on the strip may be used to model equivalent magnetic distribution in the slots, again because of the complementary nature of the strips and slots. So finally, we have some general discussion of two-dimensional entire-domain basis functions, and so they are needed to describe the distribution on surfaces when both the dimensions are comparable to the wavelengths. And these examples include metal plates, wide slots and conductors, microstrip circuits. And the complete set of entire domain basis functions for rectangular shaped geometries like rectangulars of view triangular or circular sector may be obtained from the eigenfunctions of the geometry. And electromagnetic wall cavity eigenfunctions are more suitable, and they can be determined from the cavities modal analysis. For rectangular page in the X and Y plane, the electric current may be expressed like this. So we generally want to separate Jx and Gy for to solve them, and variations of these functions with respect to x independent of the variations of with respect to y. So in this case, we can utilize a strip current basis function to develop the basis function for a rectangular page. And we consider this page with the size of L by W. The current component will be defined by these expressions. So for the accelerated current, we can write this expression, and then correspondingly for y-directed current of this expression. And these functions are orthogonal. We see that like the basis functions for the current density on a strip of wire, these basis functions do not include H singularity. So if we need for faster convergence of the solution, we can multiply both expressions by these factors. And finally, this plot illustrates the behavior of several types of basis functions for a rectangular page. And in terms of advantages and disadvantages, so the advantage of using an entire domain basis function lies in the efficiency again, as you were saying. And we may need fewer basis functions to model the expected distribution. But there are issues. So the one thing is that we need to get the function we want to simulate. The entire domain functions are not generic, so they may not be able to model, or they may require a larger number of basis functions to model, and for the case of arbitrary distribution, and especially if there is a notch or dip in the distribution. The use of entire domain basis function may make evaluation of matrix element difficult. And the last is that the stability of the matrix solution depends on the condition number on the matrix, and the condition number on the matrix increases with the order of matrix. We discussed condition number in earlier lectures. So the use of entire domain basis functions is likely to increase the condition number very rapidly with the order of the matrix. And because of this, only the first few basis functions may be useful before the instability will be increased. So there are infinitely many possible sets of basis functions for a given problem. And some sets of basis functions may provide faster conversions than others, and they give matrix elements that are easier to evaluate. The choice of basis function determines the accuracy and efficiency of solution. And the poor choice may give a divergent solution. For any particular problem, the task is to choose the correct set of basis functions, and then them are well suited for particular problem.